is the last day of lectures for the semester. Really exciting. We're going to finish up chapter 14 today. Before we do that, I want to point out a couple of things. So first thing, reminder again, the last day for any missings or makeup stuff is the 25th. So that's Wednesday next week. So if you have a boatload of stuff that you need to get caught up on, like get after it. As soon as you finish stuff, send me an email, let me know, and I'll go back and check it when I get a chance. Try not to wait till last minute if you have a lot of stuff, like send me an email as you go, right? Like a little day update, like, hey, I did this and this or whatever. You know, let me know and I'll get those in. It's easier for me to get them, you know, a little every day than like a ton all at once. If everybody waits, that's kind of a nightmare, but it'll be fine. If you haven't let me know whether you wanted to do the take a double test score or a retake, please make sure you send that email to me. So I think that most of us, have sent that. Oh no, I declined that. Most of us haven't sent that. So as soon as you know which one you'd rather do, whether you want to take the doubled high test score or to do a chapter test retake, remember the retakes are capped at 80%, send me an email. So if you know right now, you can send it right now. If you are still thinking about it, that's fine, but I need to know by Friday this week so I'm able to have everything set for next week if you're doing a retake. Any questions on that part? And I think if you did elect to do a retake, I think I sent you something back about a date. Jay, did you see my email?
Yeah.
And you're cool with that day? Okay. All right. So one last thing. If you look in the content library at the very top here, I did get the exam review in. I'll get a key in here probably by the end of this week. I just want to make sure I have a chance to double check it, make sure that there's not any like significant problems on there. But I think it's okay and ready to go. Reminder again, you get to, if you complete the review, you can use whatever you've completed on the final exam, though you do need to turn it in by the end of the day on the 31st. That's the last day of regular classes before exams start. No exceptions. You got to get it turned in before the end of the school day. That's the very last. Obviously, if you're done earlier, turn it in earlier. But that's the very last possible time you can get it in. Any time after that, I will not take it. In addition to being able to use it on your final exam, I'll give you up to 5 points extra credit based on completion towards your exam score. Cool? All righty. Should we finish up chapter 14 then today? Or, supplement B, not chapter 14. Supplement B. All right. So today we have to do B3 and B4. For B3, we're not going to do the entirety of B3. In fact, all I really want to do is talk about one single idea from B3, just because I want that tool to be able to use when we do B4. Okay? So the one idea that I want to talk about here from section B3 is using a matrix to solve a system of equations. So if you were, they needed that too. That's a hassle. She walked all the way down there. Now, anyways. So there's a couple of different ways we can do this. We're not going to go through all of the ways. I'm just going to do the one way that's the easiest. And that's the only one that you guys would be responsible for. So let's show you how to do this. So let's say we have some system. So the system that we're going to look at in this case is this one. So let's say we have some system like this. Okay? And this was something that we would have talked about when we did supplement A, right? How to solve one of these things. We could use substitution or elimination. Either one of those will work in this sort of situation. But what we're going to talk about a new method today where we're going to use a matrix to do this. Okay? So the first thing that I need to do is to make sure that my system is properly formatted, because the way we're translating the system into a matrix really matters on the way the system is written. So the first thing I want to do is I want to check that all my x's line up, all my y's line up, all my z's line up, my equal sign lines up, and then the constants at the end line up. Everybody cool with that? Now, traditionally, this is how we write our system anyway, so, it's probably fine the way it's written. But if it wasn't, or if I'm creating my own system, which was something we'll have to do in B4, we have to make sure that we're setting up our system so everything lines up vertically like that. Everybody cool with that idea? Again, very easy thing to do, but if it's, we got to make sure that it's been done. So the next thing I'm going to do is I'm going to translate this system into a matrix. Notice that I have 1, 2, 3 equations. So the matrix I'm going to write for this is going to have 3 rows. And then I have 1, 2, 3, 4 columns of information. So the system the matrix I'm going to build in this case is going to be a 3x4. I'm going to have 1 column for the x's, 1 for the y's, 1 for the z's, and then 1 for the solutions or the constants at the end. So far, so good? Now, the matrix, when I'm translating the system to a matrix, I'm going to omit everything except the coefficients. So instead of writing 2x, I'm going to write x. Instead of writing y, I'm going to write 1. Instead of writing negative z, I'm going to write negative 1. And then I'm going to write 0. Everybody's okay with how I translated that first equation into a row on my matrix? Again, really pretty easy, right? You're just taking the coefficients. If there's no coefficient, we know that it's 1. Hypothetically, like let's say that I had no x there at all. What would I put there in my matrix if there was nothing there? A 0, right? Because you could think of that as like 0x, right? Now, that was just like a hypothetical because we were talking about this, so we're not actually doing that. Everybody's cool with how we set up our system, or set up our matrix? Okay. What we're going to do now is on our calculator, we're going to use the command RREF. So what RREF stands for is row reduced echelon form. Not important that you know that, but we're talking about it, so we're going to say what it means. I think it's no H in there. Yeah. I don't know if I spelled echelon right. Spelling's hard, guys. A lot harder than math. Math has rules. Spelling's rules are all over the place. All right. And what this is essentially doing what this RREF command is doing in your calculator is, you remember how when we did elimination back in supplement A, it's basically doing the elimination procedure, but it's like hard coded in to the calculator in a way that like is functional for a matrix. So like, for example, if we went back, we might say, okay, I would take equation 3, multiply it by -2, and add it to equation 1 to eliminate the x's, right? So when we do the RREF, what the calculator is going to do, it's going to like take row 3, multiply it by -2, add it to row 1, and then store the answer over what was in row 1 before. And it's just going to do that until it's eliminated everything other than 1x, 1y, and 1z. So let's type this into the calculator and show you where that RREF command is and show you what the answer looks like in terms of a matrix and how to translate that answer into like a value for x, y, and z. Okay? So if you have your calculator with you and you want to follow along, I encourage you to do so. If you're just a sit and watcher, that's okay. You can always go back and refer to the video that we're doing right now. So the first thing I need to do is enter this matrix into my calculator. So where do I go to do that? Yeah, second, and then the matrix button is there, just a few below the second button. And once I'm here, I have to move over to the Edit tab. I'm just going to use matrix A. So that's a 3x4. And then I'm just going to type in my matrix exactly as it's written on my sheet of paper. Okay, so got mine all typed in. I'll give a couple minutes. Some of us might be a little bit slower on the typing than Mr. Kulik is, and that's okay. You take your time. It's not a race. If it was a race, though, I'd won. So just to let you know. Oh, are you tied for first? Okay. I would have won if I had a calculator to type into, because my fingers are faster than my mouse is. How's that? I'm going to put an asterisk by it. All right. Once we've got all this entered, I'm going to exit back out to the main screen. So I'll press second and then the mode button to quit to the main screen. And then I'm going to return back to the matrix menu. So second and matrix. This time I'm going to move over to the math tab. And I'm going to scroll down to the bottom until I see the letters RREF. Make sure you're careful here, because there is also an REF, which is not what we want. We want RREF. And we're going to do that on that matrix A that we just made. So I went back into the matrix menu and selected matrix A. And then I'll press enter. God bless you. Hey, you're welcome. Okay. So this matrix that we got on our calculator is considered in row reduced echelon form. That's the type of matrix that we have here. What that basically means is that I have ones along the main diagonal, zeros everywhere else, and then like a column of numbers at the end. That's what row reduced echelon form means. That's a lot of words for just like, it looks like that. But, so our answer now to the system is encoded in this matrix. All we need to do is translate this matrix back into a system. So what I'm going to do there is I'm just going to look at, remember, each row of our matrix was equivalent to one row or one equation in our system, right? So remember, the first column was our x's. So that's, or I'm sorry, the first column was our x. So I have 1x. The second column was our y, so I have 0y. The third column was our z, so I have 0 z's. And then I have an equals the last column. And what that really just says is x is equal to negative 5. Since 0y and 0z just drop out. Everybody's cool with that? I can do the same thing then for the next row. So there I have 0x plus 1y plus 0z equals 2. Or just that y is equal to 2. And then I can do the same thing with the third row. So 0x plus 0y plus 1z is equal to negative 8. Or z is equal to negative 8. So there's the answer to my system. That's pretty nice compared to what this was like doing it by hand, right? This was, especially if you catch a 3-variable system, that's kind of a time-consuming process. Lots of places to make little silly arithmetic mistakes. Does the calculator make arithmetic mistakes? No. Calculator is very good at arithmetic. Now, it'll only do what you tell it to do, so if you type in the wrong number someplace or something, it can't help you there, and it can't interpret your answer to its answer to give you your answer. But I think all that part is the easy part compared to like the tedious arithmetic it takes to like solve one of these systems by hand. Everybody cool with that? Do we need to do another example of this, or you think you got it? It's pretty straightforward, right? It's just like turn it into a matrix, type in your calculator, have the calculator do it, translate it back to an answer. There's no real math involved. You have to understand what it is you're doing. Like that's the mathematics, but like the arithmetic, the computation, the calculator will handle for us. Okay. Oops. That's all I want from section B3. So in B4, what we're going to talk about are partial fractions. And essentially, what we're going to be talking about here is, say we have some rational expression that looks like this. When I say a rational expression, I just mean like a polynomial divided by a polynomial. Everybody's okay with that? What we're going to want to do is we're going to want to break that up into the sum of two or more rational expressions. So what we're going to be worried about today is like, how do we do that? This piece over here would be the partial fraction decomposition. So that's how I can take the fraction on the left and break it up into the sum of two fractions on the right. Everybody's okay with that? All right. So let's talk about how we go about doing this. Everybody's good with that plan? So we're just going to do some examples to kind of talk through the process that we're going to use. I'm not going to give you like the fullest, detailedest example of the process because there's lots of weird things that can happen that I'm not going to worry about you guys being responsible for. So I'm just going to kind of streamline this to be just deal with the kinds of problems I would expect you to deal with, just so that you know that this is bigger than just the piece that you're going to be looking at here today. But given the amount of time we have and where we're at in the semester, that seems pretty appropriate. Okay, so we have this fraction here, and we want to break it up into the sum or difference of a bunch of fractions. The first thing that I'm going to need to do is I'm going to need to factor that denominator. So this is the first step kind of for all the problems that we're going to look at. How does that x squared minus 2x, how does that factor? This is a skill that we would have practiced a lot last year and you should still be pretty good at. And in fact, the type of factoring you're doing here is even algebra 1 or pre-algebra level factoring. So should be pretty easy. How would this factor? Yes, so what's the greatest common factor in this case? X. So we can just factor off an x and write that as x times x minus 2. Everybody's okay with that? So I have two factors here. I have the x and the x minus 2. Everybody see that? Because they're being multiplied together. That's what makes them factors. Since each of those factors are degree 1, right, I have an x to the first, and then I have x minus 2 to the first. I know that those are going to be the denominators in my partial fraction decomposition. And there's just going to be 2 of them, 1 for each factor. 1 fraction for each factor. Everybody's okay with that? What I don't know is what the numerator is going to be, so I'm going to just use a variable, an a and a b. I like to use capital letters here because I have lowercase letters in my variables, and it just can get a little bit messy, so I want to be careful. So I'm going to use like capital A and capital B and stuff. Everybody's okay with that? Okay. Now what I'm going to do is I'm going to work on this left-hand side. So the next thing I'm going to want to do is I'm going to want to make a common denominator on that left-hand side. So what do I need to multiply a over x so that its denominator is x times x minus 2? X minus 2. Yeah, it's nothing tricky, right? And then we'll do the same thing. What do I need to multiply b over x minus 2 so that its denominator is x times x minus 2? X. Everybody feel good there? So what I'm going to do next is I'm going to write this now as a single fraction. So the a distributes through, and the b times x, and that's all over x times x minus 2. Everybody so far so good? Nothing too complicated has happened yet, right? This is all still pretty realistic. I'm going to make the following observation here. Since these two fractions are equal, and they have the same denominator, that means that their numerators have to be equal. So I can just kind of drop the denominators. And that's lovely, right? And what I'm going to do now is I'm going to take the pieces that have x's in them. Well, I should say x to the first in them, and I'm going to group those together. And the pieces with a constant only, I'm going to group together. Is everybody okay with that? Again, nothing too complicated that I've done here. Although the process is getting a little bit lengthy, none of these steps have been like uber complicated, right? And we are just about to the end. So now what I'm going to notice is that, okay, well, a plus b, since that's the coefficient on the x, and I know that has to equal 3x, so a plus b has to equal 3. Additionally, I know that negative 2a is my constant, so that has to equal negative 4. And I'll write in a 0b there, just so that when I translate the system to a matrix, it's super obvious what I've done. And that's going to be my last step now. I'm going to translate the system to a matrix to solve the matrix, and that'll give me, and use that matrix to solve the system, I should say, and that will give me the solution to A and B. So I'll go second matrix, edit. So that's a 2 by 3. So 1, 1, and then 3, negative 2, 0, and negative 4. And then we'll do RREF on A. So that's going to imply what? That tells me A is 2 and B is 1. Everybody's cool with that? Notice I didn't write out all the stuff I did previously. It's not necessary that you do that, although if you make a mistake somewhere, if I know the matrix that you typed in and what your calculator output was, I can award partial credit in those sorts of situations where if you don't show me that and you just write A is 2 and B is 1, I have nothing to, to use nothing to base partial credit on. But you don't need to show it to me. So when I go back to the beginning, I had A over x and B over x minus 2. So I would have 2 over x plus 1 over x minus 2. And that's supporting what I had shown you initially, right? Sure.
How did you on your calculator get A equal to 2?
So remember, the first row is an equation. So it's saying 1a plus 0b is equal to 2. Yes, because I did the RREF on that matrix. Yep, exactly. Cool. Sure. All right, let's do one more example, and then I'll show you where this might make, or what might make this a little bit harder. Okay? We'll do one more example like this, and then I'll show you the one extra thing that could happen that makes things a little bit more difficult. But that'll be we'll be done after that. So I'm going to do like 2 more examples. Unless you guys feel like you want to see some more, we can do some more if you want. But I think 3 is probably an appropriate amount. Okay. So what's my first step? Factor the denominator. Great. How does that denominator factor? This is squarely a first semester Algebra 2 question. Remember, we have to, you're close. -5 and +3, right? Very good. So again, it has to multiply to give you -15, and then also add to give you -2. Since the leading coefficient is 1, we can do the shortcut. Okay. So I know then I'm going to have something over x minus 5 plus something over x plus 3. And it doesn't matter which one you do first or second or whatever. So far, so good? Okay. What do we do next? We got to make a common denominator. Very good. So what do I need to multiply x minus 5 by? X plus 3. And then what do we need to multiply x plus 3 by? X minus 5. Everybody cool with what we did there? Okay, I'm going to multiply everything out. And that'll mean the denominators are the same, so I'm just going to drop them also in that same step and just set the numerators equal to each other. Landon had pointed out that was coming soon, right, I think? Is that what you were getting at?
Oh, sure.
Okay. I thought you said set them equal to each other.
Yeah,
And
that's not really what I meant.
Oh.
I just said it
Oh, okay. Well, let's do that all in the same step. Everybody's cool with we doing that? All right. Okay. The next step then is going to be to group the x pieces together and then the constants together. And that is going to be what we need to write our system. So a plus b should equal 5. And then 3a minus 5b, bless you, should equal -1. And then from there, it's calculator time. And that'll give us the answer. Yeah. So this, using the calculator to kind of solve these systems, make these problems quite a bit less tedious. So I do that, I get a is 3 and b is 2. So I have hello. Ugh, come on. I love when OneNote decides to just like, yeah, just like intermittently the stylus just is going to stop working. You know, just like, yeah, you know, like you don't really need that. It's like, well, heck, I don't need that. Okay. Oh. Stylus, what are we doing here? This is a, I'm just frustrated now. We're going to take half an hour to write one answer here. And excuse me for my penmanship. You know, using your mouse is not always the most effective way of writing in OneNote. Those of you that have lost your stylus and tried to do anything in there know, like, boy, this is taking frickin' forever. Like, ugh, I need to get that straightened away, or straightened out straight away. Okay, now it's gone back to working. Lovely. All right. Everybody feel reasonably comfortable with that? Okay. Now, Mr. Kulik, you had hinted that this could be, or could get more complicated. Can I see an example of where that might happen? Sure. Let's do one more example. Let's say we have this. Notice that I've already given you a factor denominator here. But what is different than in the with the factors in this denominator that are than any of the other ones that we've seen so far? It's that piece. Why is that piece different? That's a degree 3 factor, right? There's actually 3 copies of that factor. There's 1 copy of the x plus 3, and there's 1 copy of the x squared plus 1, but there's actually 3 copies of the x. You guys see that? So here's how we account for that. This factor is actually going to create 3 fractions. So you're going to have a fraction for x, a fraction for x squared, and a fraction for x cubed. And then we're still going to have one fraction for the x plus 3 and 1 fraction for the x squared plus 1. Yeep! And I certainly did not leave enough space in between these so I could consolidate this because I'm a dummy. Okay. Common denominator time, right? What do I need to multiply x by to get x cubed plus 3x plus x squared plus 1? And x squared. Everybody okay with that? I still didn't leave myself enough space. What do I need to multiply the x squared by? Good. X plus 3, and x squared plus 1. What do I have to multiply the x cubed by? And what do I have to multiply the x plus 3 by? And then the x squared plus 1 x cubed, and then the x plus 3. Sheesh! And you can see right away that this is becoming quite a bit more stuff to keep track of, right? As soon as you introduce like a factor that doesn't have degree 1, like the problem kind of explodes and becomes much, much bigger. All right. So let's FOIL that out real quick. So x cubed, and then 3x squared, and then an x, and then 3. So I'm going to have, and then I still have to put the x squared there. So I'm going to have ax to the 5th plus 3ax to the 4th plus ax to the 3rd plus 3ax to the 2nd. And then we'll do the same thing here. So notice that this and this are the same, so they're both going to be that. So this is just going to be bx to the 4th, 3bx to the 3rd, bx to the 2nd, and then 3bx. And this is also the same. So I'm going to have cx to the 3rd plus 3cx squared plus cx plus 3c. Oh, Boise. And then we have dx to the 5th plus dx to the 3rd. And then we're going to have x to the 4th plus 3e x to the 3rd. Yikes! And all of that has to equal 12x plus 5. Okay. Let's start grouping things together. So we'll start by getting all the x to the 5ths together. So that's those. So I can say a plus d x to the 5th. And then we'll need all the x to the 4ths. So there's one there. There's one there. There's one there. So we're going to have 3a plus b plus e x to the 4th. And then we need our x to the 3rds. So I got one there, and one there, and one there, and one there. Oh my goodness, and one there. So I have a plus 3b plus c plus d plus 3e x to the 3rd. And then we're going to need our x squareds. So x squared, x squared, x squared. Okay, so just those ones. And then we're going to need our regular x's. So I have, there's one, there's one. And then lastly, we need just our constants. And that's the only regular constant term. Wowzers! Okay. So our system is going to be a big one because we have 6 equations. I think we have 6 letters, right? E is the 6th letter. All right. So notice there's no x the 5th term here. So a plus d has to equal 0. So that one's done. Then we're going to do this one. There's no x the 4th term on the left side. So that one also is going to equal 0. And we have this one. Notice there's no x cubed term on that side. So that also equals 0. And we have our x squared. There's still, again, no x squared term over there. Oh my goodness, Mr. Kulik. So that's also going to equal 0. And then that is our x term. And that, we have an x term on the other side. That's got to equal 12. And our last piece and that's got to equal 5. So there's my system. Yowza, yowza, yowza. Boy, it's a good thing we don't have to solve that by hand, right, guys? Woo! Mr. Kulik, that's crazy talk. Yeah, you know. You feeling crazy? I'm not solving it by hand. It actually wouldn't be that bad because you have one answer straight out the gate. I forget wherever I am. 5th entry. 1, 2, 3, 4, 5. Okay, so that's 0. And that's 0. Oh. What did I do? So I have 1, 0, 0, 1. Okay. And then 0. Oh, fiddlesticks. Oh boy, guys. Oh boy.
What'd you do?
I mean, it's not great. And my OneNote is froze, so that's even better. No, I didn't forget a subtraction. But it is bad. So this numerator, notice that this factor is a degree 2 factor. So what I actually need here is like EX plus F. Yeah, I know. Which makes everything a big mess. Let's quit on this. This was way harder than I wanted this to be.
So we don't have a question.
No, I'm just gonna go and like way simplify this to something that's like actually that got way harder than it was nowhere near that hard I would expect you to deal with. Let me find an example that's like considerably more realistic for us to do, and we'll do that instead. Okay? That one looks better. Let's do this one instead. This is much better. Bless you. How's that? I didn't need 7 variables to worry about. That got out of control really quickly. And my apologies. I just looked at the example. I'm like, oh yeah, we'll do that one. I'm like, oh boy, no, let's not. Okay. So this is now, I think, pretty realistic, right? So make our common denominators. Everybody okay with that? So far, so good? Okay. We'll group these together. So my x squared, oops, and then my x's, and then my constants. So my system, 0a plus b plus c equals 0, because there's no x squareds out here. And then I have a plus b plus 0c is equal to 4, the coefficient on the x's. And then 2a plus 0b plus 0c is equal to 4, the constant. That's better, right? That feels like considerably more manageable than the alphabet soup of confusion that we are playing around with earlier. You want Landon to go and finish that one from before? Oh, yeah. Yeah, I thought it was going to be hard. I didn't think it was going to be that hard. We got to 7 variables, and that was a problem. And I somehow managed to screw up this line over here also. So 1, 1, 0, and then that should be a 4. Okay. There we go. So A is 2, B is 2, and C is negative 2. So I have 2x squared plus 2x plus negative 2x plus 2. Yes.
I have a question.
Sure, what's up?
For the beginning, where it says like 2bx, which is 4x plus 4. 2bx.
Yes.
So does nothing happen to the 2?
Oh no, Victoria. Why couldn't you say something
I
earlier?
didn't know.
That's okay. Yeah, if you see me making mistakes, you're supposed to stop me. Hey, it's okay. I'm not mad. I'm just like, oh, Boise. Hey, at least this is a considerably easier fix. So that just means 2, 1, negative
I don't know,
1.
like for the equation, like you put like below it, like what happens to the 2?
Oh, sorry.
Do I just put that? Okay.
Yeah, it goes. You got to sneak it in there. Yes. So thank you. Excellent point. Mr. Kulik made a boo-boo. And a whole lesson of boo-boos. Mostly because I bit off more than I should have been chewing on that one. I picked a later example. I'm like, oh, look, there we go. It's doing what I want it to. And then I started getting into it, and I'm like, oh, this is doing way more than I wanted to. Okay. So in conclusion, like the first two examples and this last example are things that I think are realistic level of difficulty that you should be able to do. That middle or that third one that we abandoned after getting midway through, realizing that Mr. Kulik made a mistake and then not wanting to go back and sift through to fix it is way beyond what I think that you should be able to deal with. Okay? Just to be clear. We got into it, and I want to make sure that you guys realize that that's way more than you need to be able to do. My suggestion to you would be, why don't you guys try to do 63, 69, and 70? Those are the three problems from the problem set. And we can talk about those at the start of next class or whatever. Since this is, I think, the most difficult, or at least maybe the most lengthy thing we're asking you to do inside of this section or this whole chapter B. So I would suggest, even if you're not planning on doing the problem set because you don't do problem sets, or it's like, well, I get 2 drops anyways, like I've done everything up to this point, so I'm not going to worry about this. I would still do those ones just so you have a chance to practice this a little bit, because it's not trivial what I'm asking you to do, right? As you saw, Mr. Kulik just made a bunch of goofos. In fairness, that was much more complicated than the ones that I would ask you to do, but it gets they could get bad, you know. It's a relative question, right? Like even the easy ones are probably complicated for you, whereas the hard one is like that's still pretty hard for Mr. Kulik, as he made some goofies. Anyways, that's gonna wrap us for the semesters. So was Friday. You guys can start working on, we'll take some questions and stuff, but we'll spend the rest of the class working on our study guides and stuff.